positive responses from all the students. And so this talk, hope I can sort of initiate some sort of curiosity in thinking in an area called sensor networks. And I've been working on this for almost 22 years. This is just an overview, but bear with me, there will be a lot of graph and theoretical models which we have developed over the years. I may want to sort of skip it, but still try to give you an idea on the concept of this entire area. This is an emerging area and has tremendous applications in many disciplines. So this is a classic area of what I call an interdisciplinary area where computer science plays a significant role in all the other disciplines. So that you will see basically from the top. Alright, the reason I'm sort of giving you this overview in this context is funded research is very important, especially in an area like this. There's a lot of interest from many people. So then collaborations are also very important because you can't just do a research in an area like sensor networks by sitting in a university. So the other interesting theme of this conference is collaborative research. So and I hope your faculty and the students would involve in a similar way. So this, we have many funding agencies. In fact, as on today, we have new grants from various agencies, DARPA, National Science Foundation, Office of various agencies. Then if you look at it, there are many universities named, you see that. There are many collaborators because when you get a DARPA project, a DOD type of project, it is not being given to one particular university. It's a theme they develop and it is being awarded to various universities. So during the last so many years, we have always collaborated with various people. So the overview that I am sort of presenting, they also have contributed along the way on this. And as usual, there are many good students I have. And so they have also contributed a lot on these projects. Now, a project of this magnitude, it is not just the theoretical foundations that we are developing. There are a lot of implementations, there are a lot of simulation models that we have to develop. So we always had an opportunity to collaborate with the national labs because the national laboratories have much better computing facilities and they're a lot more richer than universities. So there are a lot of our former students who work there. So we had the sort of pleasure to work with many of those bright students. And there are some of our students who have spent quite a bit of time during the summers. So there are many labs involved in this work. Now, this is fairly a talk which involves three different components. One is sensing and information gathering. I mean, this is by no means a Department of Defense project, because the moment you talk about sensor networks, people always would believe, oh my God, he's only trying to work on something on target tracking problem or profiling a terrorist. I mean, we do that work also, but there are lots of civilian applications that one can think about. I had the pleasure to work with a very distinguished group of people in Korea called Korean Advanced Institute of Science and Technology. I spent last spring, quite a bit of time, and there is a paper which is coming on mobile computing using sensor networks. So I'll talk about something on sensing and information gathering, then sensor networks. Then I will also give you some theoretical ideas in defining efficient algorithms and data structures, because the underlying theme for all of these large-scale computation is how fast your algorithm is in real time. And then what is the unified data structures that we are presenting. Then we'll also talk about some of the overview, the current research work. And there are some list of open problems, The reason I always want to list some of these open problems and potential solution is, and I'm sure there are a lot of students who may be interested in this area and might think of these open problems which have not been solved might be challenging to them. So that's basically what we have done. So if you look at this slide, you've gone a long way in terms of the past and current and future. If you look at the past, the kind of bullet cards we were using, so many number of years back, then later on, the big computers. And now you see, for example, we are talking about computing in real time using some of these small devices where we have all of these processing capabilities, and that can be done in real time. So the interesting aspect of this is, in future, if you see the quadrant, we will be collecting lots of data through many of these satellites, which you will not be able to know. I'll give you some specific instances. If you go to the airport to check in, at many international airports, the moment you check in, there are lots of data that have already been collected on you. How do they do it? You may not notice there are cameras on every side. So what they are trying to do is, for example, in that context, prevent a terrorist flying into a plane, or preventing any of those kind of accidental things that can happen. So what is very critical is, there is already lots of information being collected by some device or the other while you sort of walk into the airport. And there are many, many agencies when you go, without your knowledge, So that means there is always a lot of information that people can collect, and it can happen. So satellite is one such place where there will be lots of information that is being collected on different types of applications. For example, if you are really interested in looking at the temperature variations or the population explosion in one particular area, these satellites can certainly give you some sort of an idea and some data that can be used for forecasting those kind of parameters. So what is very interesting is there is a lot of information gathering that is going on that we really do not know. Okay? Whether it's for the right purpose or for the reasons whatever that people are collecting data. Now, if you look at Moore's law, so what did Moore's law predict? It predicts a new class of computers about every 10 years. Okay? Now, in a similar context, if you look at the idea of using sensors or the development of sensors, when it is collecting large amount of data from one application or the other, that's also sort of increasing in a similar way like Moore's law. So what is it happening is you have large amount of data, okay, from every place and every source, from different devices. So the idea of this data is this data has a lot of spatial parameters, temporal parameters, which can sort of identify some sort of conditions of the physical world. So when you have this kind of data, what can you do? Now, with this data that is being collected, they are not very reliable, because sensor data is itself an area of research, inherently unreliable, ambiguous, erroneous, and incomplete. So there is a lot of challenging problems even if you have data. So there are a lot of nice, interesting methods, and I am sure the moment you have large amount of data, if you want to sort of develop some sort of correlations, what do? So the first filter that you use is sort of develop some sort of a data mining algorithms to see whether it has any association to any of the parameters of data that you are collecting. So they're like that. There are many, many interesting ideas that one can develop. Now, if you look at the RFID market alone, is believed to increase 10 times to $26 billion in 2060. You know that if you go to a very well-known shopping mall like Walmart in the United States, every item that is being sort of stored there has been sort of tagged with this kind of RFID identification. So even by chance, if you have an item which is not being checked in, and then if you go out of the counter, it starts developing some sort of a signal and alerts the person who's standing there that has not been checked out. So just to give you an idea, this kind of data identification is itself a very important business for many, many applications on that. So you can see $26 billion is quite a bit of business. So again, all that I'm trying to say is we are collecting large amounts of data. Now, so what we are really doing with this kind of data, we are sort of moving towards what we call as proactive and probabilistic computing. Okay? Now, we have computers that we can use it, that can provide right information at the right time. And then we can use it to sort of do an analysis on this kind of data. So the theme of this talk is, when you have large amount of data that is being collected, how did we collect it? It may not be an interest to us right now. Assuming that you have, so how can sensor networks be deployed with the low-cost technology to automate business and operational process flow to an environment? So the applications are sort of redundant here, because we can sort of channelize what techniques, how do you deploy it, and then how do you sort of collect the data, and so on and so forth. Because sensor networks can collect two different types of data. Sensor networks are being used for monitoring a phenomenon, whatever that is. The second thing is, if suppose there is an event that I want to detect, let's assume that there is a truck that is passing in this area and I have deployed a sensor network, then will I be able to detect that event? So we should be able to do it. So there are what are called as data collection sensor networks. Then the second type of sensor networks, they are called event detection sensor networks. So there are some small computational, computing and sensing challenges we have in each one of those networks. Okay? So now let's just see what are sensor networks, okay? And if you already know this, please pardon me, because some of these things might be a repetition for you. Now we are talking about small devices, smaller than what you see here. Okay? A device maybe of a small penny. So we are talking these devices in large numbers, millions of devices. Now, the other interesting thing is these kind of devices can be deployed in large numbers, particularly in a sort of a hazardous type of environment. Now, in an environment where humans cannot go. So they rely on wireless channels for transmitting and receiving data. Some other note. I'll give you more details on that. So the whole idea is you are talking about an autonomous system which has a large number of devices which can be deployed for various things, but I'll give you one or two methods here. And then I will also translate that into a real nice, beautiful theoretical problems too. So the device is like this. Now, these are battery powered, and they are equipped with some of these sensors. They have some data processing capabilities, I'll give you, and a short range of radio communications. Now, what is the difference between a sensor network and a traditional network? And I'm sure, you might be thinking, what is this? Now, if you look at any traditional networks, the conventional networks that we know, it has a finite topology, large amount of, power, and it has many components, fixed. But whereas in sensor networks, we have large number of tiny devices, and there is no topology for any of these devices. So as soon as you deploy these devices, what it does is it forms into clusters, small clusters, and then it establishes a radio communication within the domain, and then it connects, and then it forms a network. Now that network can change its topology in the next maybe 10 minutes, because you remember, as I said, these devices